Lee, why do we want to go to space?
It's a solid question, Rich. It's a question that I think I'll take it back to if humans stopped looking up at the stars, or if they looked up at the stars. I'll use a Timon reference here, and they look at the stars as fireflies that got stuck in the sky. Right? Our lives would be drastically different, from our history to our culture, science, technology. All this development would be remedial at best. So I wanted to take a look at a few areas of where we're seeing a major impact. First, and we've seen it over time, it's an agricultural impact. As far as seasonal indicators are concerned, the appearance and the position of certain stars and constellations in the sky have been used to mark passages and changing of seasons. For example, the ancient Egyptians would use the dog star to predict when the Nile River was going to flood. Mm-hmm. And that is a crucial part of the planting and the harvesting, right? We can see that.
Oh, yeah.
Then from an educational standpoint, that which would be the second point, previously we believed that we were the center of everything. All right. And all the stars revolved around us. But modern astronomy has disproved this. And we've looked at it now. Modern astronomy has also given us the ability to fundamental concepts of physics. You think about Newton, his laws. You think about gravity, electromagnet, all this, nuclear fusion, fission. So if you ever wanted to fly, ride a plane, if you ever wanted to produce electricity with a low greenhouse effect, this is all that's gone if you don't look up. Okay. Last thing I'll bring up is, as far as the innovation that came from it, it's really on the navigation side. I know back earlier times you'd be able to hold your hand and be able to look at the stars and understand where you were and where you're going. That's like the Greeks, the Polynesians, that crew, right? That's how they were looking at the North Star to be able to see, okay, are we going true north? And it's very interesting because the North Star is different than all the other ones because it's nearly aligned with the Earth's axis and almost remains stationary. So it's a good one to use for sure. But then we came up with the astrolabe. We came up with things like a chronometer used on maritime, being able to understand what happens on the seas. But the real claim to fame, I believe, is satellites. So in the 70s, U.S. government, they've been working on these satellites. And then I think in the 90s is when it was actually pushed out. And that provides precise location and data that is received on the ground. So when we're driving from place to place, if you're using Google Maps, Waze, any of these other applications, kaputs without this. Think about time synchronization, financial transactions, scientific research. All of this is happening because we have looked up. So I think I'll start there, pass it back to you, Rich.
That's a great spot to start. I mean, you gave us a little bit of history and segue and that kind of that fascination and where it stems from. I absolutely loved it. And of course, a Lion King reference to kick us off is never a bad thing. I am going to flip it though a little bit, and I'm going to pass this over to Jamison. Lee gave us that kind of that idealism of space exploration. However, if we look at when it sped up was with those satellites, little Sputnik, and during the Cold War. What are your thoughts, almost on the other side of what Lee just shared, on those who say that space exploration is more military driven than it is scientific driven or even that wanderlust?
So I definitely want to agree with Lee that interest has certainly been around for a very long time, and we've definitely been using the stars for a lot of things just to form our concept of extraterrestrial goings on for sure. I think it definitely, as you said, it definitely sped up during the Cold War for a couple different reasons. Military was definitely a pretty major reason for sure. We had just gotten into nuclear technology, nuclear weapons. That was a new frontier. And so for one thing, the military industrial complex was going pretty heavy on that, doing testings for nuclear bombs and whatnot. And one of the main problems for that was how exactly are we going to guarantee that we can deliver these nuclear bombs to where they're supposed to go? Which is not a super fun topic, but at the same time, it started getting onto the research topic of intercontinental ballistic missiles. And going back to Sputnik, the Soviets launched Sputnik in, let's see, I think it was like the 1947 or something. It was pretty early on.
Hmm.
And that was kind of a wake up call for the U.S. when they were able to successfully get that into orbit, because they used a previously assigned ICBM to get it into orbit. And so it was proof from the Soviets that they were actually able to launch those missiles and get those bombs over to the US, which actually was pretty much what really instigated that rush from the US. And because the military had so much money, because it was such a major benefactor for a lot of different research, not just for space and nuclear technology at the time, but also for computers as well, they definitely just started throwing money at that. And it culminated eventually in the 70s with the moon landing. And at that point, the U.S. was basically like, okay, this is the greatest achievement that we've ever done in history of humankind. Space race is over. We've done it. Congratulations, U.S. That's all. We don't want to spend much more money on this right now. But I think that was throughout that period, 30 years or so, all of that research was pretty much primarily funded by military interests. So I would say that military definitely has a massive hand in actually getting us to space, in actually achieving the dreams of our interests and our wanderlust. Of course, I wouldn't promote specifically military interest, just because again it's been around for quite a while. But with spy satellites and whatnot, those spy satellites were probably among the first practical use cases of technology in space. Both US and the Soviet Union used satellites to gather all of that intelligence on the other's military installations. Communications became more of a thing starting in the 90s. From the 70s to the 90s, it was still more specifically military, but we can see nowadays that has shifted. The military still has a pretty large hand for sure in funding, but we've seen a lot of private companies like SpaceX start to make a real business out of being able to launch different things into space reliably. So at this point in time, I would say it's not as heavily military based. I would say it's more profit based at this point. But being able to get to where we are definitely relied a lot on military research and military funding. That being said, I don't want to say that it is because of the military that we are in space. I think if we hadn't had the space race in the Cold War, there would have been some other instigator to get us there, and it may not have been military, but that's just where we are now.
Interesting. And you gave me a wonderful segue into kind of our private sector discussion. Then I'll throw Charlie a question on in a second. I'm always curious when I look at space exploration and that rapid pace of those 30 years or so that occurred. You're saying that we'd eventually get to the moon. Do you think we would have been to the moon by now if it wasn't for the Cold War?
I like to be optimistic and think, yes, most likely we would have found some other way to raise the funds to get to that point. It may have taken a little bit longer, but most certainly, I would say, because there's not just military installations in space. You can tell that at this point. The need for communication, the internet, for one thing, could have instigated something like that. Maybe not communications in terms of getting to the moon, because that's not super useful, but getting into orbit, low Earth orbit, geosynchronous orbit, all of that kind of stuff. There's a lot of different applications for that besides military at this point.
Cool.
The ISS too. There's a lot of scientific applications for sure.
Yeah.
So I think people would be interested enough that we would be able to do a lot of other things, include going to the moon without military involvement. But again, that's just the way things are.
Cool. And the ISS is actually two nations that were involved in that Cold War. All right. Yeah. Sharing the space up there. Yeah. So you two set this whole conversation up wonderfully to kind of give both sides. Let's dive into the private sector, and we'll come back to these discussions that we just had so far. Charles, we recently are seeing Boeing Starliner having these types of challenges. we're seeing the private sector try to make a splash, SpaceX and Blue Origin and things like that. But there's a lot of significant dangers that come along with going into space. Even on some of these short missions, getting stuck up there, hearing weird noises that turn out to be nothing, whatever it may be. What are the significant dangers of humans on, let's go, long duration space missions to start?
Well, basically everything in space will kill you on some level.
It's like Australia.
Yeah. So you've got the obvious fact that you have to bring your own oxygen. You have to bring your own breathable atmosphere. You have to bring your own atmospheric scrubble, clear out the carbon dioxide, oxygenate the air. That's a whole, and here's something that's very important to think about, heavy system that you have to get. Every pound that you have to get from Earth to orbit is a massive investment in money. So as we think about all of this equipment that is required to keep humans alive, think that you keep that in. There's space radiation. Now, on Earth has a magnetosphere that blocks most of the solar radiation, the cosmic radiation. But that as you get further and further out, the effect of the magnetosphere weakens, and humans are bathed in radiation the whole trip. And now, how do you block radiation? Heavy shielding. Again, heavy. There's also the effect of long duration zero gravity on the human body, which we have barely studied because the longest the longest anyone has ever spent in space is a little bit more than a year. And some of these proposed missions are going to involve years and years of space travel, which is something that we have zero data on what that will do to a human body. So even though we have gotten really good at putting things in low Earth orbit, there are still so many unknowns beyond that. And I do think it is still worth mentioning that low Earth orbit still has a lot of problems. Kessler syndrome, where debris from anything, really, preserves its conservation of angular momentum in low Earth orbit. In orbit of anything. So, if you have garbage, the space garbage, it's going to be moving around the planet at maximum speed. If it breaks up, it's going to be going faster and have more energy on impact. So what you could have is this. So as we put more and more garbage in Earth orbit, there's more and more things that spaceships have to dodge as they go up. So as space becomes more commercialized, as the private sector moves into these profit-seeking enterprises, they are going to fill space with garbage just as they fill Earth with garbage. And we stand a real risk of injuring astronauts and preventing and sealing off our access to space.
So quite a few challenges there. Yeah. So let's go through this. I'll stick with you here. So first of all, blown up satellites, right? We've seen countries actually blow up their satellites, and it goes into these millions of pieces, and that is that space debris on top of just thousands and thousands of satellites up there already. We also know that astronauts have eye problems afterwards, right?
Mm-hmm.
But I wanted to talk about the bone density.
Oh, yeah.
Right. So can you dive into there? Because that will also, we're going to talk about settlements and basically putting humans on habitable locations.
Mm-hmm.
And a factor there is going to be bone deterioration, right? Can you talk a little bit about that?
So this is a known effect of prolonged zero gravity, and again, prolonged free fall. We don't really have long-term zero gravity research, but the effect is the same. So I just want to be correct about that. So astronauts lose bone density because there's no gravitational pull on their body, so their body begins kind of like breaking down their bones. Long-term astronauts deal with this problem by exercising for 2 hours a day, possibly more. When they get back to Earth, they have to go through like this whole exercise regime to restore, their bone density in order to survive on Earth gravity. If we're talking about like prolonged people in zero gravity, they stand a real risk of just permanently losing bone mass. And we don't have any data at all on prolonged microgravity. So sure, the moon has gravity, Mars has gravity, but is that enough to keep a human body healthy? We have no data to test that, no data on that, and no real way to test it until we send some guinea pigs up there.
And in the form of humans,
In
though,
forms
right?
of humans. Yeah.
When you're up there for a while, you also have to think about people being born in those type of environments and what impact that could be, right?
Hard to get babies to do 2 hours of exercise a day to keep their bone density up.
As an adult, I have a tough time getting 2 hours of exercise. I actually want to ask a question to all three of you. We mentioned Boeing. We mentioned SpaceX. Do you think, and Jamison, you kind of hint on it a little bit before, does the future of space exploration lie in the hands of the private sector more so? Lee, I'll start with you. What are your initial thoughts?
I think so. That looks like where it's going, just because of the amount of capital that it will take to get this process up and running. So I do believe that that's where we're going, where we're headed. But in the process, the cool thing about these private sectors is that they also are more public with the information and what they're doing than, say, the military, right? So you get access to someone like Elon Musk talking to you about, okay, here's what we're planning on doing. Here's some small models of what we're trying to accomplish here. And that could lead, I'm hoping in the future, to more investors getting involved here for different reasons that may be more philanthropic. But I do know that if it was staying only at the military level, this would have never happened. At the private sector, it becomes something of private interest. So now you just have to look at the interest of those owners, and then hopefully those owners can look at the interest of their customers and equate and bring the two together and marry them together.
Sounds like the same challenge that we discussed during our AGI podcast, and some of them are the same people. Interesting. Jamison, what are your thoughts?
So I think there are three options here. First option is, again, military. We could have another space race kick up with China or something, and that would be another source of funding for sure. Commercial sector is definitely a viable option. I think that there would be a lot of government funding still going in as incentive for that to happen. I think there definitely is at this moment anyway. The other option is government choosing to have a more exploration-based initiative, sort of, but I don't see that happening until we solve a lot more problems on the planet or in our own countries. I think governments tend to be a little bit more focused on that when there isn't a military aspect involved. So I would say commercial sector is probably going to be the way to go as long as we remain in a majority capitalist world, but who knows in the future how governments change.
It'd be interesting if another country beats the US to a certain location, maybe some prime real estate on a planet or a moon that we'll talk about shortly. Charles?
Okay, got a couple things. First of all, the SpaceX accepts a fairly significant amount of its money comes from government investment. To say that SpaceX is a privately funded enterprise is let's just call it a slight exaggeration. They are very much involved in government projects, government launches, and they get a lot of resources from public funding. They're a private company, but at a certain point, the government could just declare eminent domain and say, hey, we invested most of that, but they won't, obviously. Private sector space investment is the sheer scale of money that is still required for significant space progress is well beyond the reach of even the largest private corporation. You still need government funding. The single most impressive piece of space technology in recent memory is the JWST, the big space satellite. That required international investment from multiple governments to get that thing launched and successful. And the next thing that I want to talk about is that the military is still the leader in space technology. As Lee said, they just don't talk about it. The military is still at the absolute forefront of what is possible in space and what is actually useful and meaningful to human civilization, the space telescope. That is the domain of international governments. The private sector launches are very good at kind of like routine stuff, like keeping, our communication satellites, keeping satellite-based internet, those kind launches that are better if they're as cheap as possible. But the significant advancements still require those, billions of dollars and nice cushy government jobs for the smartest people in the world.
You also got to look at it this way. Let's say that SpaceX goes public. And let's use James Webb Space Telescope as an example. There were a lot of hiccups there. There were a lot of delays. And as you mentioned, 3 or 4 countries, I think, may have been investing in that. If you're a public company that has to respond to shareholders, there is no way you can have delays, ideally, for a decade, right? How long was that delayed? That was delayed for quite a while. And so without any type of return on investment. So it would be interesting as they're kind of getting a little bit of discussions about SpaceX going public too, how that would all work overall. All 3 of you pulled the curtain out in front of us to show us, okay, wait a second, military and government is behind all this other stuff as well. Cool. All right, let's jump over to a little bit more on the tech side. Lee, what role does AI and robots play in our current space missions?
Huge role. Huge role. As we've talked about in other discussions, we haven't sent a human up that way for quite some time to be doing doing all of these mundane tasks, the routine tasks. You definitely would want to have a robot powered by AI to be able to do this. Let's just take a look, because I know we're going to talk about it later, but assuming that we wanted to know more about Mars, and robots play a critical role in current space missions by performing the tasks that are, as we talked about before, Charlie has already listed some things here. It can become way too dangerous, very complex, and then physically impossible for the humans over time to stay in that condition. So robots actually enhance our ability, right, to be able to explore, gather data, conduct scientific experiments in space, ones that may yield nothing, and we're okay. And ones that yield something great, same thing. Give you a couple examples here. We got rovers, planetary rovers. Right now we have Mars rovers. You have Curiosity and you have Perseverance. And they're designed to be able to go across the surface. And they were designed in such a way that they can handle the rocky terrain. What happens if we go up there and I turn my ankle? You can lose so much over something so little. And then as far as conducting the scientific experiments up there, trying to understand the composition of the rocks, the soil, the atmosphere, this idea that we see something that looks like it could be glacial caps on Mars. And then we are looking at the soil and saying, hey, no, there was water here. It may be a permafrost below. That oftentimes you will not be able to confirm with just the naked eye. So you would want to have a system or a robot that could do that and, connect and analyze those type of samples. We have satellite probes where we know there are many satellites in space right now that are used to study solar weather, used to study space weather, things that I would not want to get caught in. As what Charles had mentioned before, I don't want to be lathered up with radiation, right? But a system can definitely do that, or a robot can do it. Now, that doesn't mean we don't send people to space. That is not what I'm getting at all. I do believe there is a necessary need for human interaction in space. I think it should be human in the loop. So you have robots like Simon, Cimon, and this is actually designed. This robot is designed to manage the simple schedules, provide information, monitoring the environment, and the conditions of the ISS. I don't think a human needs to be there to do that. Not for those particular things. Then, Charles, you had mentioned it costs a lot of money to move objects north or into space. A lot of money. So you have robotic systems like spheres that help move this cargo and equipment around the spacecraft, reducing the physical burden of someone like you and I, right, being up there. I was taking another note here, my friend. Charlie, you had also mentioned the space garbage. Yeah, it's up there. So on Earth, we're actually working on creating these AI robotic systems to be able to recycle, right? Not recycling robots, but recycle what we put out.
Waste.
Right? Right, the waste that we put out and being able to identify that. So the same way that we're doing that here, they're trying to set it up to where space agencies are trying to set it up so that they can come up with robotic solutions to managing and capturing and removing space debris, right? So instead of having humans do that and chase down, a washing machine in space-sized satellite, going X amount of miles per hour, that could be extremely dangerous. But giving us that opportunity to knock out some of the problems that we already are facing here, we don't want to recreate that when we leave, right? And when we're doing other things. Yeah. I'll leave you with two last things. One, robotic 3D printing. So instead of taking the washing machine, you get what I'm getting at?
Yep.
3D printing up with you, way less as far as weight is concerned. Bring it up there, enabling like long duration missions. You could possibly reduce the cost. And then the last piece is, what happens when we want to come home? When we want to re-enter Earth's atmosphere, there have been movies made on this, right? Apollo 13, there have been so many movies where they were doing the calculations and are trying to confirm, are we going to land them in the place that we want them to land, right? Versus something else happening. I don't know about you guys, but I don't want to be the guinea pig for the landing, I'd rather have a robot do that. And if it blows up, man, so be it. At least I live to fight another day. So allowing these robots to go out and kind of do the things that are more dangerous, the mundane tasks, and also help us with ourselves. I think this is the area, right? This is the next step that we would need to be taking. And to not do that would be a little obtuse. But yeah, you can get the most out of it that way.
Yeah, no, great breakdown. And there's pros and cons to each, certainly, right? We need to see how the human body is with more tests and more longevity up there in space, as Charles was hinting at before. I think the most consecutive days in space, right, is slightly over a year, as you mentioned before. The cost of also bringing up humans is so expensive. Though these robots are heavy in themselves, this bag of bones and blood, I think, is one of the quotes. It costs so much to maintain the food that has to go up there, the care packages that sometimes they'll have to send on up to catch, and then obviously the security features. There was actually a very cool new kind of like helicopter that's coming on out. It's going to be sent over to Titan. We may talk about that in our next question, so I don't want to steal the show totally here. But when we're talking about machines, this helicopter, picture like Dunes helicopter, by the way, right? Especially it's called Dragonfly. I'm assuming that's kind of what it's going off of, though it looks a little bit different, as you would guess. I mean, that's going to be flying over the moon, Titan, and looking down and taking all those data points that you mentioned. That's something that, first of all, to get to, say, Saturn is 3 years, going at anywhere between 25,000 miles to 4,000 miles per hour, which is kind of what the normal pace of space crafts are. So how can a human do that, right? When we get there, first of all, could they even survive going through that atmosphere? The answer is no. It's a very thick atmosphere for Titan, but let's use Venus as even an example. That one, no. So Charles, go ahead, take it away.
You mentioned survive going through the atmosphere, which is technically true. You would survive going through the atmosphere. You wouldn't survive much past that. But you might make it enough to go technically through the atmosphere, but I really do want to stress how successful robots have been in space. Like, people kind of have this idea that the space program has been in decline, but the data that we're getting from our very successful robot missions has been fantastic. As automation gets better, as our ability to calculate gets better, we don't need we don't need all of the apparatus that keeps the rest of the body alive, so this can do the calculations. If you watched the film Apollo 13, which great movie, by the way, and it also, really happened, you see all the scenes of everyone calculating the return on slide. I actually do have a slide rule, but I don't have it in arm's reach, so
I'm not surprised.
Yeah. No. Yeah, I don't know where my slide rule is at the moment, but that's how they were calculating the trajectory. And, Jim Lovell had to add all the numbers by hand on paper in the capsule. But as robotics gets better, as our computers get better, like, there was an old joke that your coffee maker has more computing power than the Apollo capsule did, but that was a joke from the 90s. Our computers, oh goodness, what is the funniest thing I can say right here? Your fridge has more computing power than the Apollo missions did. So, by several orders of magnitude. So, for the time being, robot missions are probably the most successful return on investment that we have.
Excellent. Lee, do you want to add to that?
No, I think, Charlie, we're on the same page, right? We definitely want to bring it in both together, right? It should be like a collaboration, right, between the two. So robots, to me, in space exploration, indispensable, right? We don't do it without it for sure. But as technologies continues to advance, so will the role that they play and what we do as we go for the new frontier. So I think we have it where they are right now, but I don't want to limit them for the future in that type of capacity.
Oh, yeah. In tandem or maybe the first things that go into these zones and set it up with that 3D printing. Let's go to Jamison here. Jamison, I got to ask you this question. This is actually probably my favorite question of our conversation here today. Is there a promising candidate for human settlement beyond Earth? And let's just say that there isn't. What would be our best choice if we had to?
Well, it kind of depends on how optimistic you are, I would say. Of course, Mars. I'm going to start with Mars. Mars is probably the most promising just because we have so much data on it. Like we were talking about before, we've put a bunch of robots on Mars and we've collected a bunch of samples and we've analyzed those samples through the robots. Everything that we know about Mars is essentially from, in at least the majority of what we know about Mars is from those robots. That being said, we have the most data on Mars. We haven't been able to do too many major expeditions to other places, at least getting onto the surface of those places yet. So I'm gonna answer that second part of your question right now, just saying Mars is most likely going to be the biggest possibility for example, if we could not live on Earth, if there was some major catastrophe that made it so that we couldn't be here at all, then the next viable option would most likely be Mars. However, there are other options, and that's what makes this question so much fun. I'd say there's three different categories here. There's the in-system terrestrial planets like Mars. There's Mercury and Venus. Mercury is pretty darn hot, so it'd be kind of difficult to try and set something up there. Venus, as we talked about, has a pretty darn thick and toxic atmosphere, and it's difficult to even land on Venus. Those are pretty much the rocky planets, pretty much. So Mars, again, would be the best possibility there. Second category is moons. So our own moon, it's pretty small, so there's not a lot of gravity. And we talked about humans dealing with microgravity as well, bone density and whatnot. And it would be difficult to set up an atmosphere on our moon as well, but it is close, and that's what we have going for our moon. There is also Titan, which we just talked about previously as well. It's a moon of Saturn. It is also thick in the atmosphere category. It's got liquid methane and ethane lakes on it as well. However, the issue is that it is extremely cold, and so we would have that difficulty if we were going to attempt to make something habitable on there. And it's far away, as you said. Both Titan and Jupiter are kind of in terms of being able to compute how exactly we would be able to get there, just get there as humans. That's still something that we haven't really been able to test. Europa as well, moon of Jupiter, that's another promising aspect because it has a subsurface ocean, a water ocean, and we are definitely going to be sending expeditions there as well as Titan just to do a little bit more exploration. I think Charlie probably has the name of the project for Europa. Charlie, do you know what it is?
As he's on mute, it's Clipper, actually. Clipper.
Thank you.
Yep, that is going to be going to Europa in 2031. It will be in the area.
I was struggling to find the mute button. Sorry.
Okay.
Master of technology over here.
Let's see. What else? There's exoplanets as well. Outside of our solar system, there are a lot of possibilities, but there's also some pretty major constraints to those. One of the possibilities would be Proxima Centauri b, which is our closest known exoplanet in the Proxima Centauri system. But that is 4.24 light years away. We don't have too much data on it because it is that far away, but we like to dream about landing on other exoplanets in general. It would take a while to get there. I think with our current technology, it would probably take about 37,000 years or so, as opposed to the 3 or 4 years it would take to get to the outer system. It's kind of far away. It's a bit too far, I think.
I think to get to that, I think there's some laser sails, or if we're able to get to the speed of light ever, then we cut it down to 20 years with laser sails.
Right.
But yeah, that's probably not happening in our lifetime there, right?
Most likely not. And that's the closest one, too. That's the thing. Like, it's not even one of the most viable options. It's just the closest. There's also Kepler 452b, which has been dubbed Earth's cousin because of what we know about it due to its similar size and location in the habitable zone of the star. That one is 1,400 light years away. So a little bit farther even. We also have the TRAPPIST system, which we were able to do some pretty interesting studies on recently. I believe it has 7 exoplanets in the star's habitable zone, and each of them seems to have a different chemical makeup. So that's definitely a zone of interest for sure to be able to actually do research on exoplanets, but again, not very viable for our current technology. Definitely fun to look at and to dream about, though. So to wrap it up, I think Mars is probably going to be the most viable possibility in the near future at the very least. But here's hoping that we are able to develop the technology to go to other systems and see what's there.
We'll pick on Mars for the next handful of questions, but before we get there, I have to tell you, Charlie and I were going on a stroll yesterday, and our conversation was, of course, on different moons that could be sustainable. One that I'm very interested in, and I'll tee it up to Charles because this is the one we were talking about yesterday, Saturn's moon. There's one that also might have some potential there, correct?
So I just kind of want to mention that the moons of the outer planets are actually a fascinating topic. Like, you think, like, our moon is fascinating. It's a large lump of, presumably, a piece of the ancient Earth that kind of, like, got blobbed off in a ancient impact. But the moons of the outer planets are fascinating, and they're all, as so many of them are unique. Like, Titan has this incredibly thick atmosphere, and as Jamison mentioned, like methane lakes, and no other moon in the solar system has an atmosphere like that. And it is conditions that may be similar to what Earth's ancient atmosphere was like before life formed. So that's why NASA wants to send that helicopter there. But the moon that Rich and I were talking about is the moon of Enceladus, which also has a thick layer of ice like Europa. But when the Cassini mission was doing a flyby of Enceladus, they were able to test a stream of some water was kind of like dissipating off of the surface and into space. And so the Cassini flew through that water plume and tested it, and it had compounds that may indicate life underneath the frozen ocean. So Enceladus might be the strongest candidate for life outside of Earth at the moment. Yes, Europa has that gigantic frozen ocean, but we know nothing about what's underneath it. Whereas we've been able to test the water of Enceladus, and it says, hey, there's something here. There might be something here. And one more Outer Planets moon story. Very recently, NASA got to take a picture of a new volcano forming on Jupiter's moon of Io. Io is very volcanically active. It is the most volcanically active body in the solar system. This is because of the gravitational tidal forces as it orbits around Jupiter, agitating all of the liquid under the molten liquid under the surface. And exactly as Jamison has been showing. And so there's new volcanoes forming all the time, and we got to take a picture of one. So that was cool.
And the part is that we were able to capture that occurring because Io has tons of volcanoes,
but we actually took a picture of one forming.
I'm picturing Mordor a little bit, kind of with Io, give or take.
Yeah.
Keep an eye on Europa, Enceladus, Titan. I think those are some three primary big ones. Obviously, we're going to talk about Moon and Mars, and there's also a couple dwarf planets that might play a factor, maybe some water in there, whatever it may be. But spacecraft, we have JUICE, Juice, Jupiter's moons in 2031, and Clipper in 2031 for Europa. And that specific mission that Jamison was talking about is actually there to see if it can support life. It's going to go through and see if they can find plumes over there on Europa, and I believe potentially try to even go in between some. I think that might be some of the stuff. So very cool. Very cool. We have to wait a bit. Go ahead.
I am a fan of NASA's. Now, NASA proposes a bunch of wild missions. I really do hope we find the money to get them to build that submarine to send to Europa.
How cool would that be?
Yeah.
That'd be so cool.
To send a robot submarine to Europa, that'd be so cool.
I mean, they're sending Dune's helicopter to Titan, and that'll be 2034. Why not? It's so exciting, and we talk about the different, material or things that are needed for life to exist, and we might chime on that a little bit. But I want to bring it back to us and our lives existing maybe post the Earth, if that would be possible. So, back to Charles. Space settlements. We talked about the dangers of going to space. We hit on a little bit of some challenges with space settlements. First off, generic question, good or bad? Second one, what are some huge hurdles that would have to overcome, let's say, a colony on Mars or even the moon? Keeping that self-sustainable is one challenge, but let's even talk about how is it just going to survive even with these kind of care packages coming from Earth?
So I am going to be rude for a moment. I'm going to say that there really isn't a good reason to live on another planet. So typically you can organize arguments for settling other worlds into three categories. There's species preservation, economic benefit, and something abstract, usually mentioning the words ingenuity or spirit or destiny or other such vague terms that don't actually mean anything. So let's tackle these in order. First, species preservation. This is a silly argument for two reasons. One, that's not going to happen. Like, you can't build a sustainable population outside of Earth for the foreseeable future. And by foreseeable future, I'm talking generations. It is not if something catastrophic happens to the Earth, there is no way for a self-sustaining population to exist outside of it by the time that whatever that is wouldn't have been a problem anyway. And if I'm just going to be completely blunt here, we all really have to ask the question who cares? Like, if something catastrophic happens to the Earth, is the universe really drastically improved by the continued existence of humanity on another planet? Just this tiny population of people living in the worst conditions in the world, just suffering for generations upon generations just for the sake of saying, oh, there's humans somewhere else. Is that really good? I mean, I don't know. Maybe that is good. I just think it's a question that never comes up, that really needs to come up more when you're arguing for such a thing. Like, if, they always say, oh, what if something catastrophic happens on Earth? Well, what happens to all the people who are on Earth? Like, that's bad. Like, you should not make life worse for someone somewhere else just because there's something terrible happening on Earth. You should fix the Earth. 2, the more mundane one, economic benefit. There is none. There's basic, people talk about mining, and there's nothing in the solar system, with some minor exceptions, that is worth the cost of building mining equipment in space and then somehow getting that stuff back to Earth. That is expensive, that is complicated, and most of the materials are things that we can find on Earth anyway. So, a good test to talk to a space settlement enthusiast, like a good kind of first order filter for someone who has no idea what they're talking about, is mentioning helium-3. If they mention helium-3 in terms of economic viability for space settlement, this person doesn't know what they're talking about, and you could ignore whatever else they say. The last argument is very vague. Like this concept of, oh, humans have always been explorers. Well, some humans have always been explorers. Plenty of people have not. Plenty of people have stayed where they are and built and improved their own communities with no need of wanderlust. Human destiny in space, it has some uncomfortable historical parallels to oh, it's our destiny to expand into space, is a very presumptuous statement that's not based in fact, and has also, again, had some parallels to some historical events that historians have generally agreed were not good. So settlement in space, I think it is inevitable, but we really have to think about why. There's this push that just this abstract concept of goodness to be in space. But if you are going to propose something, you have to say, here is why. Here is what humans are going to be doing that robots can't. Or here is the reason why the people living on this settlement will have their lives materially improved by space settlement, or the lives of the entire human population being materially improved on Earth.
That's a lot. All right, let's break it down a little bit. First of all, I'm gonna pick on obviously the economics piece that you mentioned. If we find nickel and iron on asteroids and try to bring it in, and there's trillions of dollars worth of nickel and iron, there's also going to be billions of costs to get it. And then there's also something called supply and demand. there was a time when aluminum, the stuff that we get in the roll that we put on top of like food, is pretty easy to purchase and cheap. That used to be jewelry in essence, and very expensive jewelry. And so what do you think when you bring in massive amounts of nickel that is supposed to make everybody a trillionaire and solve world shortages or financial issues? No, it's just going to go even cheaper. Helium-3, in case this is the first time that you all have heard of it and not in a sci-fi movie, it's potential for fuel for nuclear fusion, which is also still in development, right? By the way, fission is the one that we think about with nuclear bombs. And by the way, helium-4 is the one that we use for balloons at parties and things like that. So this is different for helium-3. The impact of getting these type of elements or minerals. Jamison, can I tag you in for that? Helium-3, wow, there's 15 tons of it in the world right now, but maybe the moon or Mars. I think it's the moon. The moon has this abundance amount of it. Can we go there, pick it up, and bring it back? What are the challenges there?
That comes down to, I think, Charles's payload argument as well. I think if we're mining just in straight space without any particular major gravitational force nearby, it's a little easier to get to and get back from those places. But we have to keep in mind that the more we mine, the more we have to push that rocket, the more force that we need to use, which requires more fuel. And in a lot of cases, it's not, as Charles said, it's not economically viable for us to do that. And it's not necessarily bettering the lives of everybody on the planet, which I think is the more important thing to think about here. When it comes to mining on a planet, for example, if you're mining something, say, hypothetical situation, we find something on Mars that is not on Earth, it's going to be ridiculously difficult to get actual substantive amounts of whatever that thing is back to Earth. And in most cases, you're probably not going to be able to use it in the way that you would on Earth on Mars. So it's a lot, I think, a lot more about balancing how useful is that particular material. Are there actual applications that we use it for right now? And that kind of brings to mind, like, are there certain non-renewable sources of energy that we have on the planet that we are running out of that we can find in space? And the answer is not really. No. All of that kind of stuff was made previously on the planet through planetary means. So yeah, I agree with Charles, honestly. I don't think the whole space mining thing is really very viable at the moment. We need much better technology in terms of propulsion and fuel.
And I'm glad you summed that up that way. The thing to also take into account is this is not just chunks here. A lot of times it's like almost with water. Sometimes there's these pools of water on these planets or moons, but sometimes it's actually like frozen within rocks, or I think there's one of the moons where there's actually rocks in the middle of the water where it froze over. So it is not something that you go in there with a pump and pump out the water and boom, all of a sudden your settlement has it. And same thing with the minerals to get those. I mean, it's a challenge to get there. Let's jump over to terraforming Mars. And yeah, I think some of you know what type of question I'm going to ask. And let's throw it to Lee. For Mars, there's challenges for settlement, but if we could terraform it, that would help. However, the idea to terraform it was by using nukes. What is terraforming, and is it as bad as an idea as it seems like?
It's an interesting idea, for sure. Terraforming itself, it's kind of exactly what it sounds like if you break the word down. Terra means earth, and then form is also about shaping. So we're talking about shaping the earth. Or earth shaping, however you want to look at it. And basically, it's the process of modifying the atmosphere, the temperature, the surface, the ecology, the planets, the moons around it, the celestial body to make it habitable for us. And when I say that, I think back to what Charles had mentioned before, and geez, that it just doesn't even sound good coming off the tongue to mention it like that. But to answer the question, we'll be able to break it down a little bit more. So when we're talking about terraforming, say we go to another planet and we're going to terraform, we're going to have to modify the atmosphere so that we can breathe. We can't have those harmful mixtures there. We're going to have to regulate the temperature. Some of these places are extremely hot. You go closer to the sun, you already know what happens. You go further away, some of these gaseous planets are even hotter, right? You could cook a pizza in 9 seconds, that kind of thing. That type of hot. You also have water management. Water management, of course, we would need to do for sure. Let's just talk about how we would build a subdivision, and we want to have a pond in that subdivision where there is no pond. What would you have to do? Think of the things that you would have to do to make that happen, and then now take it off world, right? Yeah. And you would need to build rivers, lakes, these type of things, or go to a place that already has it. But of course, then you have to deal with the yin to the yang of everything else that might come along with it. We got to modify the surface. Okay, some of these surfaces, the soil composition is not built to go there and plant and to be able to create something that's sustainable versus saying, oh, I was just coming here for a little bit of time, but I'm going to have to go back. I cannot sustain this, and it cannot support human settlement. Let's say it can. Now you're going to have to think about introducing earth-based plants and fauna to establish a self-sustaining ecosystem. You would have to do that. And then that might help as far as producing the oxygen and the recycling the nutrients and creating a livable environment. But normally it only pushes the needle a tick. It does not do as much as what would be needed to terraform something like Mars. No, we're not even close to it by any standard. So Mars itself, to be terraformed, it's got a low atmospheric pressure. It's got a lack of oxygen, things that we need. Scarcity of accessible water. There's water there, or signs of it, but accessible water. High radiation levels because of the atmosphere and the thinness of it all. And then it's got an extremely low gravity. Okay, so if I have some type of element on Mars and I bring it to Earth, who's to say it does the exact same thing under the same conditions? Because they're not by any standard. If we go to Mars right now, we are super strong, like John Carter. We're super strong. But if you really look at it, if everybody goes to Mars, you're the same strength as you were on Earth. So it really doesn't change. You know what I mean? You're just stronger, but everybody's stronger. Nothing changed. And then the toxicity of the soil is also a key thing that we have to think about. Managing all of that and terraforming Mars, the answer is nukes. Nukes. Okay. Let me take you through exactly how they wanted to play out. It's not as effective as one might hope, actually. We're even trying to increase Mars' atmosphere. If we nuked Mars' atmosphere, we're not nuking Mars, to be clear. We're nuking the atmosphere. And if we did that, it would only change the atmosphere of 7% of Earth right now. So you really haven't done but so much. And the CO2 wouldn't be nearly enough for the planet to be able to have an average temperature, given the fact that right now it's at negative 85 degrees on average. And there's a huge swing on that too. It goes way further left. You guys might be able to let me know. I think it's like negative 160 or something like that. And then it goes above. That's a huge swing in the temperature that you have to deal with here. And it would take decades. So if we did do this, if we did nuke Mars, the atmosphere, it would take decades for any change to occur, or the change that we're looking for. The bombs will be 1,000 times stronger. But let's talk about the problem with that. Let's say it doesn't detonate in the atmosphere. A long ways off. I think it's a 20-second delay between any communication that can happen from Mars to Earth. We're talking nuclear. We're talking about dropping something like this with a 20-second delay to find out what happens. I don't think that's as responsible as we could be, right? And we don't want to be introducing ourselves to other planets in this type of way. It's also possible. Let's say you do detonate in the atmosphere, right? What happens is that there's a possibility that after you detonate in the atmosphere, there'll be a lot of dust, dirt, and debris that can cover Mars. So in covering Mars's atmosphere with this dirt and debris, you no longer are able to get sunlight. If you cannot get the sunlight, you have done the exact opposite of what you were trying to do in terraforming. It can totally block it out from that perspective as well. And the last thing that I'll bring up, just humor me. We nuke Mars. What happens if they nuke back? Right? You don't know what you don't know. And to go into a situation like that, and the first thing that you're looking to do is to bring in these type of the big guns, I'd be concerned about that. And just my final statement is if we have the ability to terraform Mars, meaning make Mars into the habitable planet of what we want it to be on Earth, we have the ability to terraform Earth. And we should just go ahead and do it here. I'm a huge fan of Earth. Not saying that we don't look up, but you should also look within. I'll leave it at that.
Awesome. I mean, when you're talking right there, I'm actually visualizing all of this stuff happening, right, overall, and I think I'm scared. I have a couple questions for you. Obviously, if it's 7% of Earth, why not just more nukes? Will more nukes give me 7% every single time? This is somewhat of a jest question, but one that someone may be thinking. Mars, is it regolith? Is that what the soil and dirt is called on Mars as well, or is that just the moon?
No, that's the soil there too. We're on the same page.
Okay. So that is also challenging for humans, potentially, right? The toxicity is also for humans, but also plants. My other thing for you then, when you do a nuke in the atmosphere like that, and it blocks out, if say it hits, right, and it blocks out, is that like a nuclear winter type of situation? Is that how it ends up being?
That's precisely the two words I wish I would have stated before. Thank you, because that's what's happening here. If you do work with regolith, what happens is this, say it works for the plant. I haven't seen it, and that's why I like to do more research on that. But if it does, I know that when we ingest it, it does not work with us. It does not work with us as well at all. It's definitely toxic. And if you're looking at this nuclear winter, that's the word that describes exactly what I was talking about before, as far as having that coverage and no light being able to get in, which would actually make the planet colder than what it currently is.
Yeah, interesting. And I think there's also some challenges with that type of kind of lunar soil, with being able to create babies, potentially as well. There might be some issues there. My last thing, just to kind of add to you, is you're right. With that nuclear reaction, it could drift to us. Though I believe Mars, I have it over here, is 140 million miles away at some points. We have had Mars debris come to Earth. I think there was a massive rock that told us a lot about it. I forget the name of it. I actually think it's called Black Beauty now that I think about it. And it was over 3 billion years old, and it came from Mars to Earth. So you're right. That type of waste or pollution, however you want to describe it, could drift back towards us. Team, in the essence of time, we have a handful of other great questions. I want to keep going. Lee, thank you for that breakdown. Literally going to be thinking about that for a while. Jamison, I'm going to jump straight to this one question for you. Who owns territory settlements?
So there is a international treaty called the Outer Space Treaty of 1967. This is like the foundational international agreement that governs these activities of countries in space, and it was signed by, I think, over 100 nations, including major spacefaring powers like the US and Russia and China. And basically what's stated in there, there's some nuclear stuff in there as well, banning particular types of nuclear activity. But in terms of who owns territories, there is no sovereignty in space. So the Outer Space Treaty states that outer space, including the moon and other celestial bodies like Mars, is not subject to national appropriation. This means no country can claim ownership of any part of space or any celestial body. So in legal terms, outer space is often referred to as the common heritage of mankind, which I think is kind of silly, but you know, people say it. So it's meant to be free for exploration and use by everybody, with benefits shared by all nations. So when it comes down to, I don't know if this will happen in the near future, but if it comes down to finding the best spots on Mars, people are going to have to talk about that and try and figure it out, or else it might come down to blows. But again, we have this space treaty in place, so it would be interesting to see how people resolve something like that, or if it's going to be a more community-based kind of thing.
In the history of humanity, do treaties normally hold up when there's, say, land at stake?
No. Not at all.
Right. So I'll mention, and especially when it's such prime real estate. So, you know, the book that actually Charles and I are reading back and forth and sharing notes, it is right over there, A City on Mars by Wiener Smith. And they mention the moon, there is that spot where it gets sunlight all the time. And obviously sunlight can be transferred into energy. The amount of space that is 2 tennis courts is what they share. So that is not large. That is not large at all. And if it's such prime real estate, I mean, there's been wars fought over a lot more and a lot less at the same time. I'm just saying, I don't know. I don't know how long that treaty is going to hold on up. And it's a very vague treaty, correct?
Oh yeah, it's vague and it's general too. It covers so much different stuff. Just the name of it, the Outer Space Treaty. It's just a treaty about everything that's not on Earth. Okay, cool.
You only need one treaty. It covers everything.
I guess so.
Yeah. And I believe it's only like 3 pages long. I think it's quite short. We'll see. There's not a lot of samples out there. There's not a lot of situations. And when these treaties occur, it's normally, we want to say proactive, but a lot of times there's some reactive factors or some things in place that are similar with the ocean, right? Who owns certain parts of the ocean or how far off the coastline, whatever it is, that becomes more defined in time. And even Antarctica, you can kind of take up and look at stories about that. I'm actually going to jump to this question, and it's because I want to stick with the technical side of things. Lee, back to you here. When we reach artificial general intelligence, and we talked about that in our last one, where basically machines can do anything that we do within reason, and enough to send up to space, and they handle everything for us. Let's just paint that picture and make it generic in that situation. Would that take away from the awe that kind of, wow, I love space exploration, humans can go do it, that destiny that Charlie was hitting at, or that way you explained it in the beginning? Does that take away the awe of humanity going to the stars, or does it do the opposite? What do you think?
No, I don't think it takes away the awe. Not for the person who's interested in understanding the why behind it, right? Once you do that and you start realizing what was put into it and the amount of brain power that had to go just for this system to do what it's currently doing right now, yeah, it's a beautiful thing. It's beautiful and terrifying at the same time, I'd say. So, but when we're talking about AI robots and the significant advantage for space exploration, it's good. It's very, very good that they can go first to, as far as human life, and they can see the risks before they happen with us. Things can happen that way. That's good. That's not bad. I do want to give a quick example and just kind of paint a picture, because we're talking about robots that will have Gen AI capabilities and be able to make decisions on their own. Is that correct?
Mm-hmm. Yeah, and even going one more step down that fantasy scenario, AGI.
AGI, yes.
Mm-hmm. Yeah.
Not only make decisions, but also take it to the next level. Okay. Now, I want to give you the example of an earthly. Let's take Earth and what's currently happening right here before we look elsewhere. Let's say a bank wants to invest in algorithmic trading, right? And algorithmic trading is basically just analyzing various amounts of data from the market and make rapid trading decisions based off of patterns and trends that you and I, if we looked at that set of data at one time, we would not be able to kind of gain the same insights. But in doing this, that bank now is able to maximize their profits. They become a stronger player in the market in minutes, just in minutes. That sounds pretty awesome. That's the beauty.
Yeah.
Okay, let's talk about the beast. Here's the kicker. Many of these AI algorithms operate in a black box, which are notorious for the lack of transparency. So while a decision may be made by an AGI system or an AI-powered system, the outstanding results, we know the input and we understand the output, but we don't know the why in between. So what happens now is when that system starts making decisions, it won't really consider industry fines, penalties, lawsuits. It's not considering that. And that's just for a bank, let alone that same system, you give it the same prompt in healthcare. It's going to do it the same way and just to give you the same answer, but it's like a superpower serum that we're injecting into our system without understanding all of the side effects. Insert Bruce Banner here, that type of thing. So if you did this, if you put these AGI powered systems and you let them go and just do whatever they thought was best, you can run into issues like unpredictable behavior, ethics, for sure, safety concerns, data integrity. Even if it is doing everything right, what happens when the data becomes corrupted? Right? Cybersecurity attacks. Say I send something up Charles is sick of me. He gets with Jamison and they hack my systems. You know what I mean? I'm not saying, Charles, you would do it, man, but this idea that everybody is following treaties is, so it's kind of the same thing here. So legal liability, all of that would be taken in consideration. I would not go and introduce that type of system without full control at the end of the day, because it would not be wise. I'll just leave it at that. We could talk more on it, but that's where I stand.
Thank you for that, Lee. I got to ask the other guys as well. Charlie, does it lose its luster for you? I know this answer, but for this, this exploration, right? We go into all these different locations outside of our solar system, let's say things that we will never reach. Does it actually entice you more when we are able to send robots out there who can potentially maybe even build their own version of a settlement and expand up there?
But just to give a little bit more of a substantial answer, I do actually have some evidence that people would be equivalently enchanted by outer space exploration, whether by robots or by humans, and that is, again, the Space Telescope, the JWST. People love those images of galaxies that are billions of light years away. People like look at pictures of the Horsehead Nebula in incredible resolution and are in awe of the majesty and scale of space. This is a thing that humans will never see. And not even including advanced technology, because the Horsehead Nebula is, of course, millions upon millions of years old. The light is just getting to us. So it is, by this point in actual time, if you're a physicist, pretend I didn't say that, it's very different. But humans are still enamored by this. Before I kind of downplayed abstract concepts of the allure of settlement in space, but I do want to emphasize that a lot of this discussion is centered on tangible benefits. NASA is, of course, a publicly funded institution, and might be the single greatest expenditure of public funds in human history because of the research and product development that has come out of NASA. It has to be public. We're paying for it, so all of those benefits are distributed. All of that research is distributed. And so you have things like medicine and packing materials and mylar balloons, the essential aspects of modern human civilization. And Tang, let's not forget Tang, everyone, drink of the future. But there is a genuine, I do think that it is pretty something that is universal is this desire to know. You can look at the universe and say, I am able to know what that is. And that is the product of research. That is the product of technology. That is the product of disseminating that information to civilization. And whether a human takes a picture on Mars or a robot takes a picture on Mars, for the average person, there's not going to be much of a tangible difference. People love pictures of Mars. People love pictures of quasars. And the source of that picture is not going to be something that most people are going to put a huge weight on. Let me put it that way. It is obviously impressive if we get a human to Mars, but in a wow, cool, look at what we did kind of way.
Okay, I like that last part. I want to throw a scenario then at Jamison after this, and this will segue into our next question. We look at, you and I both share a passion for history as well. You look at Rome, and, I could see the Colosseum in pictures. And awesome. Wow, it's amazing that that's still standing, kind of halfway almost. But isn't there like a desire to go see it in person yourself? And if, Jamison also just came back from Africa and he's sending these amazing pictures every day. And I love those pictures. It's one of the things I look forward to. However, I'm like, man, I want to go see that. Do you think that is similar type of feeling that could happen? Like, again, when Charles is mentioning the Horse Nebula or Mars or whatever it is, I may be in that minority outside of the horrible situations of just being in a small spaceship for years and years and years. But I want to see it. I want to see it with my own eyes. You don't think there's any difference there? How do you feel?
I think there is a difference. I think there is an advantage to both having our main tools of exploration be machines, but also taking into account the, I don't know what a good, like the best word for it is, but I would say tourism, like the space tourism aspect of it. And I mean, that's what I did in Africa, right? I knew, for one thing, I knew that it was safe, right? I knew that I was in the capable hands of a guide who was experienced in that particular area. And I'm sure, like I can't completely empathize with you because I did go to Africa, but I'm sure that it is better having been to Africa as opposed to just seeing the pictures. That being said, I think we travel from a tourism perspective for a different reason than exploration. And I think exploration is for the betterment of every single person on the planet to be able to expand our horizons and our view of the universe as a whole. And then I think travel is to change ourselves, to be able to get that experience and be able to equate it with all of the other experiences that you've had. That's more of an individualistic endeavor, but it's still important, right? It still changes us. It still makes us more sympathetic, more empathetic of everybody else around us. Now, a lot of that comes into play when there are already people there, because that is, I think that's the main driver of change when it comes to tourism, is being able to see how other people live and what other people do. And I think that is certainly augmented when it comes to space tourism, because at least in the early days, before you have human settlement, you'll basically be doing tourism with a bunch of robots and whoever else is in the tour, right? Yeah. There aren't going to be humans, most likely, when you are traveling to a particular place at first. I think that's probably going to be the main process, is we'll have machines on that wherever we go, and then we'll have people who are visiting, who are doing research, and then we'll have people who can pay, who know it's safe, and then we'll have a lot more people there. But I think the tourism aspect is definitely part of that, and I think it's a unique experience for sure. I just think it's going to be, at first, people who can pay.
Yeah, I like the way you broke that down. Exploration is different than tourism. Not everybody has that Mengellan type of desire in them. And Mengellan didn't make it back. So in that situation, that's how it would be in space. So I'm going to ask you this next question. Let's go back into a little more technology, but more futuristic. The concept of human hibernation on ships. Just to give distance, Pluto is 3.6 billion miles away. At current rates, that will take us 9.5 years to get to. We talked about, well, first of all, technology not allowing that right now, but also the cost of something like that to sustain a humans, even maybe one with a robot or two with a robot. Hopefully the robot is not named Hal. And nonetheless, that would cost so much in weight. It'd be almost impossible to get to. So a theory is that human hibernation could work. How would that happen? And if possible, is that what gets us to these far off locations?
Now that is an excellent question, and it's definitely still something that we are doing a lot of research on, right? We haven't exactly figured out how to do this just yet, but there are certain avenues for sure of research. So again, suspended animation or hibernation, still speculative, but something like cryogenics cryogenic sleep or torpor would definitely make resources a little bit easier to handle, as well as the mental part of the trip. I cannot imagine being cooped up in a tiny little rocket for 9 years with not too much to do, really. I think, especially when there are multiple people doing something like that, things can get kind of crazy. I'm sure that I think there are at least a few movies on something like this, and I'm actually thinking about a series myself about doing something like this without hibernation. But I think as soon as we have the technology to do this and it's well tested, we will certainly be using it, because it is just logistically just a much more viable option. So I think, let's see. So current research, both the NASA and the ESA are investigating possibility of using particular torpor-inducing methods for long-duration space missions. Anything that spans like decades or centuries is pretty much viable for something like this. Anything beyond centuries is definitely something that we have to think about a little bit more, I would say. But it's definitely still under heavy research. There's not really a lot that we can do at the moment besides just continue trying new methods or undergoing heavier testing with the methods that we have. But the hard part about testing that is we actually kind of need people, right? Or at the very least, a model organism to go into space and be in space for this long. And we haven't been able to do that, really. We haven't been able to test what actually even happens when we're in torpor, what happens to our bones, what happens to our metabolism. That's still stuff that we have to test out. So I don't see that happening anytime soon, which kind of blocks all of our farther away missions, at least with humans, to the long term.
And is that right now at this point the only way that we get into the stars?
Well, from a human perspective, biologically, if we want to actually put our bodies onto other celestial bodies, yes, most likely. There's also the concept of arc ships, where we have generations or generation ships, basically people staying in space for a very long time. And there's a lot of other problems that go into that, for sure, including how exactly do we keep a population in space without hibernation? Can we even have babies in space? Is that something that we can actually do? How would we keep the gravity in a ship like that? And also there's the additional, there's another concept that we might get into a little bit more depending on time, but mind uploading, which is basically being able to transfer our entire minds through essentially just light, and being able to have a presence on another celestial body, most likely through some kind of machine interface.
A robot, right?
Right, exactly.
Gotcha.
That seems more viable, but at the same time, we still have a lot of studies to do, both in AI and in consciousness in general, psychology, neuroscience, all of that kind of stuff. It's just all of these concepts are just so far away that it's hard to actually predict any kind of near future advancement in that regard.
Yeah, I mean, even just thinking about that, being kind of sustained in a computer and then being moved into some people would like that. We got the thumbs up. Some people would like that. Hey, you actually go ahead.
That's why I wasn't really worried about sending the robots. There's a chance I might be able to experience in the robot.
Well, I mean, how crazy is it to think about that? Like, just what that could lead to. Let's take out the petrifying pieces of, wait a sec, I can't feel my body, or can I? I don't know. But how cool would that be that then you're put into a robot anywhere in the universe? And I'm assuming in this scenario you could turn off and go into sleep mode, and then you wake up, like you said, more than centuries later. Interesting. I want to segue because you almost touched on it. I think you were leading there for us, but to Charles, there are theories that maybe there are things like Death Star structures, to continue with our multiple movie references today, that are intended for long-term habitat. And they could be an option. There's some challenges. Jamison actually hit on them with gravity and things like that. But can you tell us how that would work technology-wise before you tell us how it won't work?
Structures like that, well, they would be a very simple shape. Like, the Death Star was a big ball. The more likely shape of something like this, I would say, would be a big cylinder, so you could spin it for artificial gravity, and there's some kind of longitudinal thrust axis, so that everything is pretty uniform. A structure like this would be wildly mechanically complicated, so you want to minimize those complexities as much as possible. So you may have heard of an O'Neill cylinder, after Dr. O'Neill, who was a big fan of these back in the 70s. Now, again, we're kind of dragging things back to like the nearer term rather than mind uploads or human hibernation, but building a big rotating habitat in space is both a better and worse option than trying to settle another planet. Better in the sense that you have complete control over the environment. You don't have to worry about terraforming. You don't have to worry about any kind of habitation. You don't even have to worry about the concerns of bone loss, because you can just spin it at 1G and you get 1G of gravity. It's more complicated because building like a tent city on Mars, you probably wouldn't build it. You'd probably build like an underground thing on Mars. But building like a tent city on Mars is a couple hundred meters of fabric versus the colossal amounts of metal that you would need to build an O'Neill cylinder. So, so in terms of just once an O'Neill cylinder is built, it's probably a better option than settling another planet. Also, because also in the middle of the cylinder, you have a very controlled zero gravity environment, which can help with manufacturing certain things. But the question of building it is a wild kind of challenge. And here is where I do want to give credit to space mining, where if you build the O'Neill cylinder near where all of the metal is, you find a big, dense metal asteroid. So that is possible, but mining and manufacturing equipment that works in 0G is an insane technical challenge. So
that was my next question to you, is pulling some asteroids there and maybe use all that nickel or iron or whatever.
I do have like two quick points. First of all, space mining. If we're moving asteroids around to get their materials, we are, and let's not mince words here, launching giant chunks of metal from orbit at the Earth. Which I don't know if you've ever heard of rods from God, which is a weapons platform that are just these giant tungsten rods dropped from orbit, and they hit with the force of a nuclear bomb. So I think some regulations are going to be important if we're going to start, mining asteroids and launching, weapons grade chunks of nickel all around the solar system. And and I do want to bring up space nukes. Because nukes, or rather nuclear propulsion, we're not talking about dropping a nuclear bomb, we're talking about building a nuclear reactor that can provide thrust. All of our time estimates for space travel that we've had in this entire discussion assume chemical propulsion. Because chemical propulsion is the only thing we know how to build right now, and it's pretty good. But NASA and the Department of Defense, I'm blanking on the exact agency, maybe during the edit we'll pop up an article about it.
We'll do that. Yeah.
Are working on building a nuclear space rocket to be launched in the coming decade or so. Or at the very least, researching it. And space nuclear is incredible because it slashes travel time and it slashes travel expense. Not Earth to space, but Earth orbit to other bodies. And the scale of thrust that you can get from a nuclear rocket changes a lot of these discussions in terms of both travel time and travel health, depending on how many G's of acceleration you're able to crank out of your nuclear thruster.
Excellent. And then I know you love this part. We just get helium-3 from the moon, and then we get it even cleaner with the fission. And oh my gosh.
Now I do want to say a shout out to fission here, because I know we're all like, fusion is, the holy grail of nuclear research. But fission engines are really light. And so you can you can give a ton of specific impulse to a spaceship using a comparatively tiny nuclear reactor using a little bit of uranium.
Mm-hmm.
But again, that's a nuke in space. So someone might have some questions.
Yeah, and it's not even allowed in this treaty.
Yeah.
I'll tell you, we're covering a lot. I'm going to go skip a few questions. We're going to leave some further discussion for maybe a follow-up here. But real quick, don't look up. A movie that tells you what happens when you let an asteroid come to Earth because you want to mine it for all the stuff that will just be saturated. I was hoping from when you're building this Death Star thing that you do all that up there and far away, ideally, and not crazy enough to bring it in. Hopefully nobody does that. Yeah. So I'm gonna ask you guys a question, and I'll start with Lee. After our discussion today, and obviously the research that you did through this, I don't want to use the word ever, but do you see humans getting to a self-sustaining habitat outside of our solar system? And if you want to put a time frame on that, you can in your response.
No, I don't see us moving outside of the solar system within the next few generations, especially to come. I don't think that would happen. There's so many technology advances that would need to take place ahead of time for that. And I don't think we are addressing the elephant in the room. And that is that if an AI system, AGI system, a system that has its own thinking, were to evaluate the human species, would they look at it as a virus, or would they look at it as something that they would want to have moving out into the world? So from that standpoint, if we can get to the point to where we would come together as one planet and are starting to move to other planets, then I think that this planet alone would have enough to sustain. If we can get to that point to where we're looking at it from the same way as when the astronauts, when they first went to the moon and they sent the photo back, and we just saw it was one world. Mm-hmm. I mean, we may be different, but it's only one world here.
Overview effect, I believe, right?
Right. So I don't believe that we move outside of this solar system until you can do that. And I believe if you do move out before you do that, you will just have another repeat situation that you currently have here. And then it won't really matter anymore. It would be just like a virus moving from one planet or one host to the next host. And I'm not saying that humans are viral in that sense. Some try to go viral, but that's not what I'm getting at here. What I'm saying is that I don't believe we have the capacity yet on our own planet to go and really start putting flags in the ground on others.
Makes sense. Okay, cool. So fix what we have at home first, and then move on.
It's the only way. And if we can't do that, then we shouldn't. Right. So then the question becomes mute at that point. If I'm just looking at the concerns of what could happen elsewhere, that have already happened here.
Your answer is responsible. It's just, there's everybody responsible. Jamison.
I think I completely agree with Lee on this. I think we have some problems to fix on our own planet before we really start spreading to other places. The one thing that I wanted to add is the particular problems, scarcity and poverty, scarcity of particular resources and poverty in select areas, right? We, as Americans who are pretty privileged, we live a pretty good life, but the average person is not a middle-class to upper-middle-class American. The average person does not have the same kind of privileges that we have. And until we're able to standardize our standard of living to the point where everybody is comfortable and there aren't any issues that we run into in terms of resource scarcity, because that is the main issue, then we're going to be spreading all of those worries to all of the other places that we go to, and we won't be able to deal with them in the same capacity that we can even deal with them now on Earth. So that's the main reason why I don't think that we should expand in terms of human habitability. In terms of machine exploration, we should go as far as we possibly can. Honestly, I think we should just get going on that front. But when it comes to humans going off planet to other places, that's not something that needs to happen until it really needs to happen. And we have a lot more improvement that we have to do in terms of population management and being able to create these gigantic, wonderful, problem-ridden cities on the planet. Like, I don't see us getting off planet as humans until the entire planet is filled with cities that are functioning on a scale that there is equality and inclusion everywhere. And that's not going to happen anytime soon, I don't think. We've got some other problems to fix first.
Interesting. It's interesting you both have that type of thought as well. It's a great thought. Charles, wrap us up here.
So the book that we were talking about, A City on Mars, by Zach and Kelly Weidersmith, the phrasing that they used, wait and go big. Incremental, sending people to Mars to build stuff, sending things to the moon, I think that is an expensive and ultimately doomed enterprise. We keep doing research. We keep exploring Mars. We keep exploring not just Mars. We keep exploring space. We keep exploring science and technology to build not just the physical tools that will let us induce hibernation, that will let us recalcify our bones in low gravity environments. We build the social tools that can organize massive communities of people, or rather organize the distribution of resources to those massive communities of people. Once we have those tools, I do think it is inevitable you're going to get enough people who want to live on Mars for its own sake. The overwhelming sentiment here is that there are problems to fix on Earth before attempting to build anything outside of Earth.
I love it that you guys wrapped it up with that, because it's just so important to look here before we necessarily go to the stars. We'll see how it all plays out. Jamison Ducey, Charles Dunn, Lee Evans. This is Codex.